So in this question, a telescope of aperture diameter 5 meter is used to observe the moon from the earth, and distance between the moon and earth is given 4 into 10 to the power 5 kilometer. So the minimum distance between 2 points on the moon's surface which can be resolved by using the telescope is close to, and they have given the wavelength of light 5500 Armstrong. So let's solve the question. So here the figure is not visible, but I will try to explain. This is O1 and this is O2. So the distance will be O1 O2, which will be equal to d theta. And you need to remember that minimum angle for clear resolution theta is equal to 1.22 lambda by a, and lambda they have given 5500 Armstrong. So to calculate the distance, we have to calculate this distance. Distance is equal to O1 O2. So this is this, which is equal to d theta, and theta we already calculated. You can see from this 1.22 lambda by a. So substitute this value. Now for calculating distance, we will simply substitute the values. So 1.22 into 5500 Armstrong means 10 to the power minus 10 meter, and the distance between sun and earth and moon, it is given 4 into 10 to the power 8, and a it is given 5. So it is coming 53.68 meter. So our nearest option is 60 meter.